Right, this example, find the number of ways where 4-digit numbers can be formed, and you want it to be greater than 3000 from the choices of 5 different digits here, 0, 1, 3, 4, 5. First, there are 3 parts, right, where repetition of digits are allowed, no repetition digits allowed. Part 2 is no repetition of digits allowed, and the number is even number, and so on and so forth. So let's deal with it one at a time, and you can see some lessons learned from the 3 different parts. So first one, no repetition allowed. We've done it before. Good practice is to, again, create the spaces here, create the slots here. Because you want greater than 3000, the first digit is very important, right? The first digit is crucial, all right? So this one, the first one is crucial. You want it to be greater than 3000. You can only choose between 3, 4, and 5. So therefore, you have 3 choices here for the first digit. After you have chosen one, right? Let's say 4 or 3 or 5, doesn't really matter. You are left with 4 other choices for the second digit, correct? So it's 4 choices. After that, you have 3. After that, and then 2. So later we're going to do multiplication. Why? Because it's a successive operation. Now this part here, 4 times 3 times 2, essentially it is out of the remaining 4, correct? You P3. This is the same. It's actually 4 times 3 times 2. So either you do it like that, alright, or you take 3 times 4 P3. So either way it's fine, not a problem. Final answer 72. Let's take a look at part 2 now. Part 2, and there's an added layer to it where you want the number to be an even number. Now, you still want it to be greater than 3000, so you have a restriction as to the first digit. If you want it to be an even number, you have also another restriction for the last digit. The last digit must be an even number if you want the number, the 4-digit number to be even. So we have a slight problem here, because if you have chosen say for example a 3 here, right? Your last digit can be either a 0 or a 4. But suppose you have chosen a 4 here, then your last digit, you only have one choice here, which is a 0. So then should this be a times 2, or is it times 1? Follow what I'm saying? So this creates a problem, right? This creates a problem. So the way to do it is, because there is this 2 different parts to it, right? Your first digit and last digit have got problems. The best way to do this problem is to break the cases up. What do I mean? We break the cases up and say, okay, case 1 is the first digit is a 3 or a 5. Now, if it's a 3 or a 5, your last digit can be a 0 or a 4. No problem. If your first digit is a 4, then your last digit can only be a 0. Follow what I'm saying? Yes? So therefore it becomes very, very clear cut. If you break the 2 cases up, then after that, you add them up together. Add the number of ways together. So if it's a 3 or 5, then you have 2 choices for the first digit. No problem. Either 3 or 5. So this one must be 3 or 5. After you've chosen a 3 or 5, then handle the last digit, because the last place must be a 0 or a 4. Right? 0 or 4. So another 2 choices. Now after you eliminated 1 and 2, you are left with, for example, 3 digits. Correct? 3 digits. So therefore, you either say 3p2 or you say 3 times 2. This one, or you can say 3p2. No, not a problem. Right? Times or 3p2. Then we are done. What about case 2? Case 2, now your first place is a 4. There's no question. So there is only one way. And then the last place must be a 0. There's also one way. Also one choice. In between, right, you are left with also 3 times 2. right? You are also left with 3 times 2 because you are left with 0 and 4 out. These 3 times 2. Again, same thing. Or this one, it could be 3p22. Right? It could be 3p2 as well. So final answer, you add them up. The case 1 and case 2, you add up because they are mutually exclusive. I repeat many times, you must know exactly why you add the cases up. You add the cases up because they are mutually exclusive. Right? Case 1 and case 2 are mutually exclusive. That's why you add the cases up. Good. Last case. Now your repetition of numbers, digits are allowed. So you must also remember you still want it to be greater than 3000, yeah? So the first place here, it cannot be anything. It cannot be 5 choices, right? It must either be 3, 4, or 5. Therefore, you can only have 3 choices here, right? Because it can either be 3, 4, or 5. You want it to be greater than 3000. But after that, anything goes, correct? Let's say you have a 4 wiser. After that, it can be 5 choices because it can be 0, 1, 3, 4, 5. Another 5 choices for the third digit. Another 5 choices for the third digit. No problem. Then again, because it's successive operations here, yes, successive operations, you multiply them together. You will get this. But not the final answer yet. I want to emphasize this. Your 3 choices here, you could have chosen 3 here, correct? Because you chose it. The next 3, you could have 5 choices, 5 choices, 5 choices. You could have chosen 1, 2, 3, 4, 5, any one. You could have chosen 0 here for the second digit, 0 here for the third digit, 0 here for the fourth digit. You will realize that you would have formed the number 3000. But you don't want 3000 because you want it to be greater than 3000. You must minus away that one case that you chose that 3000. Therefore, final answer is 374. That's that. Thank you.